The hidden story of Wi-Fi, from necessity to invisible power. Wi-Fi is so deeply embedded in modern life that most people no longer notice it. It is not something we consciously interact with, it is simply expected to be there. At home, at work, in cafes, airports, hospitals, schools, and even in the most remote locations, Wi-Fi has become as fundamental as electricity or running water. Yet unlike those older infrastructures, Wi-Fi is invisible. It moves silently through the air, carrying conversations, memories, decisions, and entire economies without leaving a trace we can see. But Wi-Fi did not appear magically. It was not created for entertainment, social media, or convenience. It was born from limitation, frustration, and a growing realization that the world was becoming too complex to remain physically connected by wires alone. To understand Wi-Fi, we must first understand the problem it was meant to solve. In the early days of computing, machines were large, isolated, and immobile. Data lived inside a single device. If information needed to move, it moved slowly, on paper, magnetic tape, or physical storage. As computers became smaller and more powerful, the need to connect them grew rapidly. Networks emerged, but they were rigid. Every connection required a cable. Every new device meant more wiring. Every change in layout demanded physical reconfiguration. Offices became dense forests of cables. Universities struggled to provide network access across large campuses. Military and scientific institutions faced even more serious challenges. They needed secure, flexible communication systems that could adapt quickly to changing environments. Wires were vulnerable. They could be damaged, intercepted, or simply impractical. The question was no longer whether computers should communicate, but how they could do so without being physically bound. The idea of transmitting data through the air was not new. Radio technology had existed for decades. Signals had crossed oceans, connected ships, guided aircraft, and carried voices across continents. But data communication required something more precise. Digital information is sensitive to interference, noise, and distortion. Unlike voice, it cannot tolerate ambiguity. A single error can corrupt an entire message. For years, wireless data transmission remained unreliable, slow, and expensive. Early experiments proved the concept but not the practicality. What was missing was not imagination, but refinement. One of the most unexpected breakthroughs came from a field far removed from consumer technology: astronomy. Scientists studying faint radio signals from space faced a similar problem. The universe is full of noise. To detect meaningful signals, researchers developed advanced methods to filter interference and extract clarity from chaos. These techniques, originally designed to listen to stars and galaxies, would later become essential for wireless data communication on Earth. It is one of history's quiet ironies. Technology developed to explore the cosmos ended up connecting living rooms. By the late 1980s and early 1990s, conditions were finally right. Computing power had increased, microprocessors were faster and cheaper. Digital signal processing had matured, and most importantly, the demand for mobility was impossible to ignore. In 1997, the Institute of Electrical and Electronics Engineers introduced the first 802.11 wireless networking standard. It was modest, slow, and limited in range. Few people noticed, fewer still believed it would matter. At the time, wired Ethernet was faster, more reliable, and already well established. Wireless networking was seen as a niche solution, useful in specific environments, but unlikely to replace cables. Even its creators did not fully anticipate its future. What changed everything was not technology alone, but behavior. Laptops became popular. People began to move while working. Offices transformed from fixed desks into flexible spaces. Universities needed students to connect from anywhere on campus. Businesses wanted networks that could adapt instantly without construction, rewiring, or downtime. Wi-Fi offered something revolutionary: freedom from location. Early adoption was cautious. Security was weak. Speeds were inconsistent. Connections dropped unexpectedly. But each generation improved. New standards increased bandwidth. Encryption became stronger. Range expanded. Reliability increased. Slowly, almost invisibly, Wi-Fi stopped being an experiment and became an expectation. Homes were next. As internet access moved beyond a single family computer and into multiple devices, Wi-Fi became the only practical solution. Running cables through walls was expensive and impractical. Wireless routers solved the problem effortlessly. A single device could connect an entire household. Then something subtle happened. People stopped thinking about how the internet arrived. They only noticed when it didn't. Cafes transformed into workspaces, airports became temporary offices, public spaces evolved into connected environments. The boundary between online and offline blurred. Being connected was no longer an action, it was a state of existence. Wi-Fi did not just change technology, it changed human behavior. Work became asynchronous, communication became instant, information became constantly available, expectations shifted, delays felt unnatural, silence felt uncomfortable, disconnection felt like isolation. Yet Wi-Fi's influence goes far beyond convenience. Healthcare systems rely on it for real-time data access. Logistics networks depend on it to track global movement. Education systems use it to reach millions of learners simultaneously. Entire financial systems synchronize through invisible wireless connections. Modern cities pulse with wireless data. Sensors monitor traffic, weather, energy use, and security. Smart homes adjust lighting, temperature, and security automatically. Wearable devices continuously collect biological data. All of it moves through the same invisible medium. But this raises deeper questions. When information moves through the air, who controls it? When connection is constant, what happens to privacy? When everything depends on Wi-Fi, what happens when it fails? These questions grow more urgent as Wi-Fi continues to evolve. Today's challenge is no longer speed alone. Modern Wi-Fi standards can already deliver more bandwidth than most users require. The real challenge is scale. Billions of devices now compete for the same shared spectrum. Smartphones, laptops, televisions, appliances, vehicles, and industrial systems all transmit simultaneously. Wi-Fi 6 and newer standards were designed to address this reality. They focus on efficiency, coordination, and density. Instead of simply increasing raw speed, they manage how devices share time, space, and frequency. The goal is not just faster connections, but smoother ones. Behind the scenes, Wi-Fi has become extraordinarily complex. Algorithms decide which device speaks, when, and for how long. Signals bounce, overlap, and adjust in real time. All of this happens automatically, without user awareness. And perhaps that is Wi-Fi's greatest achievement: invisibility. The more essential it becomes, the less we think about it. But invisibility has consequences. When infrastructure fades from awareness, dependence grows silently. Entire societies now assume continuous connectivity. Emergency services, transportation systems, and communication networks rely on wireless stability. A disruption is no longer an inconvenience, it can be a crisis. Natural disasters, cyber attacks, and technical failures reveal how fragile invisible systems can be. When Wi-Fi disappears, confusion follows. Systems stall, information fragments, coordination collapses. This raises a profound question. Have we built a world that can only function when the air itself cooperates? At the same time, Wi-Fi continues to push into new territories. Remote regions gain access where physical infrastructure was never viable. Developing communities leapfrog older technologies entirely. Wireless connectivity becomes a tool for inclusion, education, and economic growth. Yet access is not evenly distributed. Digital inequality persists. For some, Wi-Fi is unlimited and invisible. For others, it is scarce, expensive, or unreliable. The same technology that connects the world also highlights its divisions. Looking forward, Wi-Fi is not slowing down. It is integrating with other technologies: cellular networks, satellites, artificial intelligence, and edge computing. Boundaries between systems blur. Devices switch seamlessly between networks without user intervention. The future is not about choosing how to connect. It is about never having to choose at all. But this future also demands responsibility. Security must evolve alongside convenience. Privacy must be protected alongside connectivity. Awareness must grow alongside dependence. Wi-Fi began as a solution to a technical problem. It became a foundation of modern civilization. And now, it challenges us to think carefully about the systems we can no longer see, but can no longer live without. Perhaps the most important question is not how advanced Wi-Fi will become, but how consciously we choose to use it. Because the moment the signal fades, we are reminded of something we often forget. The invisible things we rely on the most are often the ones that shape us the deepest. Subscribe to the channel, turn on notifications, leave a comment, like, and share this video. And explore the channel for more hidden stories behind the technologies we use every day.